Exercise 3.1. Identify the quadrant in which an angle of each given measure lies. Let us remember the quadrant idea. Angle starts from 0 degree as we move on. 10, 20, 30, 40 and so on up to 90 degrees. Keep on moving. 100, 110, 120. When I come here, it is 180 degrees. As we keep on moving, 200, 220 and so on, 270 degrees. And finally, back here it is 360 degrees. One complete rotation from here to here we call 360 degrees. Each quadrant we say 90. 1 into 90, 2 into 90, 3 into 90, 4 into 90. When I go in anti-clockwise direction, like this way, we call angle to be positive. When I come in clockwise direction, we call angle to be negative. So we measure in this way, it is positive angle. I measure in this way, it is negative angle. Now let us look at these angles given. 25, 0 to 90 will come in which quadrant? First quadrant. So this I will say first quadrant. It is below 90 degrees. It will be in first quadrant. 328. Where will it come? From here I keep on moving. 328 is between 270 and 360. So 328 will come here. What quadrant is this? 1. This side I go anti-clockwise. 2, 3 and 4. So 328 is here. So which is fourth quadrant? Minus 230. When the angle is negative, go in clockwise direction. So if I keep on moving, this is minus 90 because I go in clockwise. And this is minus 180 when I keep on moving like this. And I will be here when it is minus 270. So minus 230 will be here. From minus 180 to minus 270. So it is in second quadrant. Similarly, see this angle minus 55. Where it will be, if I start moving, 0 to minus 90 is fourth quadrant. So minus 55 will be somewhere here. So that is fourth quadrant. Now we have marked the quadrants only from 0 to 360, either in plus direction or in minus direction. Now the question is 825. When it is more than 360, I start from here, I go one round. So if I go one round, it is 360. If I go another round, it is 2 times 360, so it is 720. Again, I have to go. So 720 plus 90, like that it goes. How to check it? So what should I do? When the angle is bigger, subtract 360 from it. I get 5, 6, 4. Again it is more than 360. So again you subtract 360. My answer is 501. Where 105 will come? 0, 90, 180. So 105 will come in which quadrant? Second quadrant. So we will say this is second quadrant. Whenever the angle is more than 360, what should you do? Subtract 360, one method, or else divide by 360. Ignore the quotient. Quotient tells me how many rounds I am making. These are circular. Angle, I start from here. One round I make, it is 360. Another round I make 2 times 360, that is 720. Another round, I can keep on circling. So angles, when we go to trigonometry, we call them as circular functions because same position it will come again and again. Infinite times I can round. So 825 is a number which is more than 360. Two methods. Divide by 360 and find out the remainder. One method. Or keep on subtracting 360 till you get a remainder which is below 360. And now 105. 105 will be in second quadrant. So this is another method. 825 divide by 360, which is 720. The balance is 501. So we see only the remainder, not the quotient. Quotient tells me how many rounds I make. Ignore that. The remainder is my answer. So that answer lies in second quadrant. Tells me I am in second quadrant. And this is how we find out where the particular angle is. Exercise 3.1, question number 2. For each given angle, find a coterminal angle with measure of theta such that theta is between 0 and 360. What does this tell me? Theta should be positive. And we need to write coterminal angle. What do you mean by the word coterminal angle? Alpha and beta are coterminal angles if beta can be written as some multiple of 360 plus alpha. Multiple of 360 can be either positive or negative. See, k value can be +1, -1, +2, -2, anything. Let us remember the quadrants. 0 to 90 first quadrant, 90 to 180 second quadrant, 180 to 270 third, 270 to 360 fourth quadrant. When you are given an angle more than 360, either you divide, take the remainder, or if division is difficult, subtract 360 and take the remainder. Look at the first problem. It is 395. 395 is more than 360, so you subtract. My answer is 35. So how do I write it? 395 can be written as, how many times I subtract 360? One time. 1 time 360 plus 35. Look at the formula that we have written. K into 360 plus alpha. 1 time 360 plus 35. 35 is called the coterminal angle. So to say it in simple words, any multiple of 360, ignore. Write the remaining. And we need the remaining angle to be a positive angle between 0 and 360. The second one, 525. Same pattern. From 525, let me subtract 360. What is your answer? We get 165. So I can write 525 as 1 into 360 degrees plus 165. 165 is between 0 and 360. So that is the coterminal angle. 1150. As it is little bigger, let me subtract. 1150. First time I subtract. Again I subtract. Again I subtract. So what is my answer? How many times I subtracted? 1, 2, 3. So I will write, this is 3 times 360 plus 17. So 1150 is having the coterminal angle 70 degrees. When it is minus 270, I add 360. Usually when bigger angle comes, I subtract 360. Now I add 360. What is my answer? 0 and 9. So I get minus 270 can be written as 1 time 360 minus 19. But it is minus 270. So how should I write it? Minus 1 time 360 plus 19. So my answer is minus 360 plus 90. Look at the formula. K can be any number, can be positive or negative. This angle must be positive. So we get coterminal angle is 90 degrees. Minus 450. How to write minus 450? First time. Minus 450, I add 360. What is my answer? 0, 9. I get minus 90. Can I write minus in my question? No. My answer should be from 0 to 360. So once again add 360. What is my answer? 0, 217. So we get minus 450 is how many times I did? 2 times. Minus 2 times 360 plus 217. Minus 2 times 360 is minus 720 plus 270 gives me this answer. So 270 is my coterminal angle. So it's a simple problem wherein all the bigger angles we subtract 360, or in other words divide by 360, consider the remainder. That remainder should be between 0 and 360. Whenever it is negative angle, instead of subtracting 360, you add and write. Accordingly, change here and write it. So here I subtract, I write plus 1 time. Here I add, remember to write minus times. Check every time the right and left are exactly equal and then write the coterminal angle. Let us recall the basic concepts of trigonometry ratios, what we had learnt in standard 10. Consider a right angle triangle. Trigonometry. Triangle, metry tells me measurement. So it is basically a division of mathematics which deals with right angle triangles, or I can say triangles. In a triangle, if I consider this is 90 degrees, opposite to 90 degrees I call hypotenuse. If I call this as theta, the side near theta, near, we call adjacent. The side against it, opposite. The side opposite to theta we call opposite side. The side near theta we call adjacent side. So what are the ratios that we remember? Sin theta, opposite by hypotenuse. Cos theta, adjacent by hypotenuse. Tan theta, opposite by adjacent. We have 3 more, the reciprocals of the basic ratios. Sin theta, the reciprocal we call cosecant theta. Cos theta, the reciprocal is secant theta. Tan theta, the reciprocal is cot theta. The next idea, the identities. What do you mean by the word identity? For any angle theta, this equation is satisfied. Equations generally tell it is satisfied for a particular value of x theta, like that. The word identity, mostly we put 3 symbols here, 3 lines. That tells me theta can be any angle. Any angle satisfies the equation. That we call identities. We have the major 3 identities. Cos square theta plus sin square theta is 1. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. From this, I can rearrange. Wherever I see 1 minus sin square theta, I can immediately say cos square theta. 1 minus cos square theta is sin square theta. Secant square theta can be written as 1 plus tan square theta, or tan square theta can be written as secant square theta minus 1. So 3 identities are given, but you put left and right. However I rearrange, you must be thorough with it to attend the exercise problems. Exercise problems are just playing with sine and cos. Remember the identities. If they are in your hand, nothing is difficult. Exercise 3.1, question number 3. If A cos theta minus B sin theta equals C, show that A sin theta plus B cos theta equals to plus or minus root of A square plus B square minus C square. This is given to us and we need squares in the question. So, squaring on both the sides. Expanded A minus B the whole square. A square plus B square minus 2AB. Right hand side we have x square. This is actually what we want. Call this as some x. Squaring on both the sides, we get this is equal to x square. As I square and write, this is A plus B the whole square. Call the first one as 1 and what we got now as 2. Adding both, we write one below the other. A square is common, cos square theta plus sin square theta. B square is common, sin square theta plus cos square theta. Here I have minus 2AB sin theta cos theta. Here I have plus 2AB sin theta cos theta, which gets cancelled. As we are adding C square plus x square. My question is, what is this x only? So, as I take A square common, cos square plus sin square is 1. B square common, sin square plus cos square is 1, which is equal to C square plus x square. Find out what is x square. X square equals A square plus B square minus C square, and so x is equal to plus or minus root of A square plus B square minus C square, and that is the question. So actually what we want is A sin theta plus B cos theta. This is equal to x is actually A sin theta plus B cos theta, and the answer that we get plus or minus root of A square plus B square minus C square. Question number 4, sin theta plus cos theta equals m. Show that cos power 6 theta plus sin power 6 theta equals 4 minus 3 m square minus 1 the whole square by 4. Sin theta plus cos theta is m. In the question, I want m square. So, squaring on both the sides. Expand this A square plus B square plus 2AB. Whenever I have sin square plus cos square, remember my answer is 1 by the identity. Bring 1 to the other side, bring 2 down. LHS we will start with. This answer we shall mark number 1, which we will use later. What is the LHS? Cos power 6, sin power 6. We know identity with sin square and cos square. So write cos power 6 as cos square theta the whole cube. Sin power 6 as sin square theta the whole cube. This is A cube plus B cube formula. How to rewrite it? A cube plus B cube is A plus B the whole cube minus 3AB into A plus B. Wherever A is coming, put cos square theta. Wherever B is coming, put sin square theta. As I expand, LHS we have written, which is nothing but A plus B the whole cube, cos square theta plus sin square theta the whole cube minus 3AB cos square theta into sin square theta into A plus B cos square theta plus sin square theta. Again, this answer will become 1. This answer also becomes 1. So, this exercise is mainly designed for us to remember wherever sin square theta plus cos square theta comes to put 1. So, I get 1 cube is 1 minus 3 sin theta cos theta the whole square I can write because both are squares. This is also 1. Now, This sin theta cos theta we have already derived in equation 1. Use that. Instead of sin theta cos theta, let us substitute m square minus 1 by 2. So I am substituting from equation 1. As we write, square, denominator 2 square is 4, LCM 4 ones are 4 minus 3 divided by 4, and that is the RHS. So problems like this we have already studied in standard 10. Anyway, we are recalling mainly to remember the identity sin square theta plus cos square theta equals 1. Question number 5, subsection 1, to prove that sin power 4 alpha plus sin power 4 beta equals 2 sin square alpha sin square beta. When I see the question, what is given, I compare. In my answer, only sin is given. So, wherever cos is coming, rewrite it using the question sin square alpha plus cos square alpha equals to 1. So, wherever cos square alpha is coming, put 1 minus sin square alpha. Cos power 4, rewrite it cos square the whole square. The next step, wherever cos square is coming, write 1 minus sin square alpha. Cos square beta tells me 1 minus sin square beta. Cross multiply. As we cross multiply, this is a minus b the whole square. A square b square minus 2ab into sin square beta. Here when I cross multiply, sin power 4 alpha into 1, sin power 4 alpha into sin square beta. The denominator we cross multiply here. The next step, 1 into sin square beta, 2 sin square alpha into sin square beta, sin power 4 alpha into sin square beta. See, anything gets cancelled. Sin power 4 alpha sin square beta plus symbol minus symbol cancels. This sin square beta in the left and right also gets cancelled. Bring sin power 4 to the left side, minus 2 sin square alpha to the other side. So we get the required result. The question is to check sin power 4 alpha plus sin power 4 beta equals this. And so we have derived sin power 4 alpha plus sin power 4 beta equals 2 sin square alpha sin square beta. For the second subsection, use this idea. Subsection 2, to prove that cos power 4 beta by cos square alpha plus sin power 4 beta by sin square alpha equals 1. Let us use subsection 1 result. Sin power 4 alpha plus sin power 4 beta equals 2 sin square alpha sin square beta. Substitute what is sin power 4 beta from here. What is sin power 4 beta? It is 2 sin square alpha sin square beta minus sin power 4 alpha. This answer we are going to substitute. Here sin square common. 2 sin square beta minus sin square alpha. Sin square alpha can be cancelled. We are left with 2 sin square beta minus sin square alpha. How to write cos square alpha? It is 1 minus sin square alpha because it is fully containing sin. Cos power 4 we have written cos square the whole square. Cos square is 1 minus sin square the whole square. Expand this and write. This also I write 1 minus sin square alpha. As I cross multiply, 1 into 2 sin square beta, 1 into sin square alpha. Sin square alpha into 2 sin square beta, sin square alpha into sin square alpha. So we are just cross multiplying. The denominator 1 minus sin square alpha, I can write cos square alpha after taking LCM. The next step, numerator. See, any terms get cancelled. Plus 2 sine square beta minus 2 sine square beta gets cancelled. Sine power 4 beta plus sine power 4 alpha. I can write what? 2 sine square alpha sine square beta. So this and this will get cancelled. 1 minus sine square is cos square. Cos square by cos square is 1 and that is the RHS. Question number 6. If y equals 2 sine alpha by 1 plus cos alpha plus sine alpha, prove that 1 minus cos alpha plus sine alpha by 1 plus sine alpha equals y. Here y, here also y. Let us compare what is changing. 1 plus cos alpha is here, whereas here minus symbol is there. So copy the given question. Put cos alpha at the end because 1 sin alpha there is no change. Put bracket for this. So this is first term, this is second term. Now multiply and divide by the conjugate. In trigonometry, most of the problems we use conjugate multiplication. What do you mean by conjugate? I have plus symbol, I will multiply and divide by minus symbol. So 1 plus sine alpha, no change. Plus cos is here, I put minus cos up and down. As I check, these two are same. I treat it as A. Here plus cos, here minus cos. Treat it as B. So what is the identity? A plus B into A minus B is A square minus B square. 1 plus sine into 1 plus sine, 1 plus sine alpha the whole square. Cos square alpha. So A is 1 plus sine alpha, B is cos alpha. The numerator I can write as it is. 2 sine alpha, 1 plus sine alpha minus cos alpha. Write it as it is from here. Denominator A plus B the whole square. 1 sine square, 2 sine alpha minus cos square alpha. 1 minus cos square alpha. We know 1 minus cos square alpha is sine square alpha. From where I get it? Sine square alpha plus cos square alpha is 1. So 1 minus cos square alpha sine square alpha. Wherever we get 1 minus cos square, I can write sine square alpha. The next step, already 1 sine square alpha is here. So sine square plus sine square, 2 sine square. In both the terms, 2 sine alpha is common. If I take it out, 2 sine alpha is taken out, sine alpha plus 1 left out. We can cancel 2 sine alpha in the numerator and denominator. We are left with 1 minus cos alpha plus sine alpha by 1 plus sine alpha, and that is the question. We have shown y equals to this answer, and that is the question.